Hi students, today I am taking mole concept. This is actually a continued part of the last session. So in the last session I discussed few MCQ based on mole concept, and in this video I am explaining 8 MCQ based on mole concept. So let us start with the first question. Let me read it first. X liter of N2 at STP contains 3 into 10 to 22 molecules. The number of molecules in X by 2 liter of ozone at STP will be. Right, the condition is given here, right? Mentioned already. It is at STP conditions. And we know at STP conditions, equal volumes of gases contain equal number of molecules. So if you know that, we can easily get the answer for this question. Okay, so equal volumes of the gases contain equal number of molecules. So we can take any gases right here. So you can see the two gases given here, one is nitrogen, other is ozone. So if it is equal volume, they should contain same number of molecules. Number of molecules also given here. You can see what X liter of N2 will be having 3 into 10 to 22 molecules. Now they're asking for ozone, which is X by 2 liter. So what they've done here, volume is reduced to half, right? So if volume is reduced to half, we need to reduce number of molecules also to half, right? So we should divide this by 2. What you can write now? X by 2 liter of ozone will be having 3 into 10 to 22 by 2 molecules of ozone. So the right answer, if you simplify it, will get answer as 1.5 into 10 to 22. So we used only one concept here to solve this problem. Equal volumes of gases contain equal number of molecules. Okay, and we applied that because it is mentioned at STP conditions. Okay, right. So the right option for this question is option B. Let's go to second question now. 1 liter of gas at STP weighs 1.16 gram. Okay, the mass of 1 liter of a gas is given. It can possibly be, right, which gas it can be. Okay, so they're asking which gas or can take 1 liter of which gas at STP will weigh 1.16. right. Now if you take again STP conditions, we can take in terms of volume, right? If we take 1 mole of any gas will occupy 22 point, we can take 22.4 liter, right? So 1 mole of any gas will occupy 22.4 liter at the given conditions here, given condition as STP conditions. Okay, so now what they mentioned here, 1 liter of a gas will weigh 1.16. okay, so at first I taken here 1 liter is equal to 1.16 gram at STP conditions. Now if you take 1 mole of any gas, that will be having 22.4 liter at STP conditions. Okay, now can you get mass of 22.4 liter of gas? 1 liter is 1.16, then 22.4 liter will be having or weighing how much? 22.4 into 1.16 equal to 26 gram. So we got mass of 22.4 liter of gas, right? That's nothing but 1 mole of gas. So 1 mole of a gas will weigh 26 gram. This is nothing but what you can write now. We can call it as molar mass, right? Because we got for 1 mole. So if you get molar mass as 26 gram, and you can see the options given there, which one is having molar mass equal to 26. So you can easily select, right? The right answer for this question will be option A, C2H2, ethine, or you can take it as acetylene. Okay, the right answer is option A. Let's go to next one now. Third question. The charge on 1 gram ion of Al3 plus is, right, so be careful about what mentioned here in this question particularly. So it's given as 1 gram ion, not 1 gram of Al3 plus. Okay, we already know 1 gram atom 1 gram molecule or 1 gram ion is nothing but 1 mole of that substance, right? So if we take 1 gram ion, nothing but it is 1 mole. So be careful, they're asking the charge on 1 gram ion of Al3 plus. Okay, right. So now what we got here, 1 gram ion means they're asking for 1 mole of Al3 plus, what charge it is having. Okay, now 1 Al3 plus, if we take only one aluminum ion, Al3 plus ion, it will be having, it's having 3 positive charge, right? So if we take charge in terms of coulomb, it will be what? 3 into E. E we can take in terms of coulomb, like 1.6 into 10 to minus 19 coulomb, right? But all options you can see in terms of E only, so I have not taken the value of E here. So we can write in terms of like 3E. So 1 Al3 plus has a charge 3E. Then what we are finding here for 1 mole of Al3 plus ions. So what you can do now, 1 mole of aluminum ions will be having 1 Al3 plus is having 3E as charge. Then 1 mole will be having, we need to multiply Avogadro number. So Na into 3 into E. So this is the total charge of 1 mole of aluminum ions, Al3 plus ions. Okay. So the right answer for this question is, you can take it as option D, 3 into Na into E in terms of coulomb. Right. Let's take fourth question now. The charge present on 2.8 gram of nitride ion in terms of coulomb. Okay. So again, based on the charge and mass is given as 2.8. At first, you convert this mass into number of moles. We know number of moles calculation, right? We can take by mass by atomic mass, right? Atomic mass of nitrogen is 14. So we can take 2.8 by 14 is equal to 0.2. So we got number of moles of nitride ion here, right? Okay, now each nitride ion, N3 minus ion, has what charge that we need to find now. So we can take charge easily, you can see right there it's having minus 3 charge, right? So we can take like the charge will be 3 into E, right? And E value oddly I said, right, it is 1.6, or can take 1.602 into 10 raised to minus 19 coulomb, right? Okay, so as it is having 3 minus charge, so charge will be 3 into E. Now, so this we got for each nitride ion, right? Now what they're asking here, 2.8 gram or 0.2 mole of N3 minus will be having, right? You can take 0.2 moles and each mole is having Avogadro number I have taken here, 6.022 into 10 raised to 23 into each N minus 3 is having 3 into E, right? E value is 1.602 into 10 raised to minus 19. So after solving this or simplifying, you will get answer as 5.78 into 10 raised to 4 coulomb. Right, so in this way we can get the answer. So the right option for this question is option A, 5.78 into 10 to the power 4. Right, let's go to fifth question now. Fifth question is, equal masses of hydrogen, nitrogen and oxygen are taken in a container in identical conditions. The ratio of gaseous volumes are, okay, we need to find the ratio of gaseous volumes here, and it's mentioned identical conditions, right? All the gases. So we can again take, right, equal volumes of the gases contain equal number of molecules. So what is given here, they're asking what, the ratio of gaseous volumes, right? And we already know V proportional to number of moles. So if we get the ratio of number of moles, it's nothing but the ratio of gaseous volumes, right? So here we need to find the ratio of number of moles of the three gases, right? Hydrogen, nitrogen and oxygen. Right, let us see the first one. You can see hydrogen, nitrogen, oxygen. The molecular masses, you can take hydrogen as 2, nitrogen 28 and oxygen is 32. And they mentioned equal masses of hydrogen, nitrogen and oxygen. So I taken their equal mass as x. So mass of each gas to be taken as x gram. Now how to get number of moles? Number of moles can be taken as mass by molar mass, right? So I taken first hydrogen here, x by 2. For nitrogen will be x by 28, and for oxygen it will be x by 32. So this is moles ratio. Okay, why you found moles ratio here? Because to get gaseous volumes or ratio of gaseous volumes, we can even get it in the form of number of moles also. Okay, now just simplify this. What we need to do, just multiply by 32, so you can get simplified form. If you multiply each of these numbers by 32, so the first number x by 2 into 32 is converted into what? 16x. Then x by 28 into 32 will get 8 by 7 into x, and x by 32 into 32 will get 1x. So the ratio will be 16 is to 8 by 7 is to 1. So the ratio of gaseous volumes, or the ratio of number of moles of hydrogen, nitrogen and oxygen will be in the ratio of 16 is to 8 by 7 is to 1. So the right answer is option C. Okay, let's go to 6th question now. X gram of element P. Okay, first given is element P, atomic weight is given as 15, contains Y atoms. Okay, number of atoms is given. How many atoms are contained in 2x gram of element Q having atomic weight 30? Right, so two elements given. First one is P and second one is Q. Mass is given, right? X gram of element P, right? And 2x gram of element Q. Atomic weight is also given, right? 15 for P and 30 for Q. Now we can easily find number of moles again, mass by atomic mass. So we can take x by 15. This is number of moles of element P. Okay, and x by 15 moles of P is having Y number of atoms. Okay, it's given here, right? In the problem it will be having Y atoms. Now what about next one? Element Q, if you find number of moles here, 2x by 30, so we'll get again x by 15 only, right? So it means what? Number of moles is same, right? Again here, and if you take number of moles equal, it will be having equal number of atoms. So if P is having Y atoms, then Q should also have the same number of atoms because of they're having same number of moles. So the right answer for this question is option D, Y atoms. Okay, let us take 7th question now. Two elements A and B form compounds AB2 and AB3. Okay, so two elements A and B combines to form AB2 and AB3. If 0.25 mole of AB2 weighs 16 gram, so mass of molecule is given, right? 0.25 mole, and 0.25 mole of AB3 will weigh 20 gram. Okay, then the atomic masses of A and B respectively are. So they're asking atomic masses of A and B. So I have taken atomic mass of A as X here, that's assumption I made, and Y is taken as atomic mass of B. So it means we need to find X and Y. Okay, the first molecule given is AB2, second molecule is AB3. Now if we take AB2, 0.25 mole of AB2 will weigh how much? 16 gram, and 0.25 mole of AB3 will weigh 20 gram, right? Okay, now just convert or can write the expression for a mole. So if we take mole is equal to mass by molar mass, right? So this formula I can see here, it's the same, right? Number of moles is equal to mass by molar mass or molecular mass. So 0.25, okay, this I applied for AB2 and this is for AB3. So for AB2 what do you get now? 0.25 moles equal to mass is how much given here? 16 gram. So I take a numerator 16 gram divided by, okay, now molar mass, how to get that? The formula is AB2. So I take an atomic mass of A as X and B as y. So what you get then, AB2 means x plus 2y is the molecular mass of AB2. So 16 by x plus 2y, and if you cross multiply you will get the expression like x plus 2y is equal to 64. This is the first equation you got, right? Okay, so you got an equation like x plus 2y is equal to 64. Now the second case for AB3, so what is given there? 0.25 mole will weigh how much? 20 gram. That's the mass, divided by molar mass, the molecular mass is x plus 3y, because the molecule is AB3, x is atomic mass of A and y is atomic mass of B. So if you simplify it, you'll get the equation like x plus 3y is equal to 80. So we got two equations here having two variables x and y. Then you can just solve it to get x and y values, right? So what I have done here, this equation number 2 and equation 1. So I have taken equation 2 minus equation 1. So x cancels, and then y is equal to 16 you got, right? Okay, if y is equal to 16, based on this only you can get the answer, right? They're asking atomic mass of A and B. Okay, A I have taken x and B as y, right? So y is 16. You can see only one option in which y is 16, right? So you can select the answer as 32 and 16. Even for confirmation you can just find it by using any of the equations. So x is equal to 80 minus 3y, then 80 minus 48, it will be 32. So the right answer for this question is option C. X is, or atomic mass of A is 32 and atomic mass of B is 16. Right, so that's the 7th question. Let's take the last question now. How many moles of electron would weigh 1 kilogram? Right, number of electrons we need to find, sorry, number of moles of electron we need to find, which would weigh 1 kg. Okay. Right, all of you know mass of one electron equal to, in terms of kilogram, you can take it as 9.1 into 10 raised to minus 31 kilogram. Then if we take number of moles now, if we take 1 mole of electrons, it will weigh Avogadro number into the mass of each electron, right, or one electron. So this is Avogadro number 6.022 into 10 raised to 23 into mass of one electron is 9.1 into 10 raised to minus 31. Okay, so this is 1 mole of electrons mass in terms of kilogram. Now just see what the question, how many moles would weigh 1 kg? Okay, so in this place, let me show, in this place what we need now, 1 kg, right? Okay, so we can see here, we need 1 here, right? So take all these numbers to the LHS part. So if you take all the numbers to LHS part, what you get? All goes to denominator. So 1 by 6.022 into 10 raised to 23 into 9.1 into 10 raised to minus 31. Okay, this is LHS part is number of moles, right? Okay, these many moles equal to, now what you got, 1 kg, right? Okay, so you can just write in other form, as you can see the options not given, right, like this. So you can just simplify these two, right? 10 raised to 23 and 10 raised to minus 31, right? So it will be 10 raised to minus 8, and if you take to numerator it will be 10 raised to 8. So 1 kg of electrons, nothing but 1 by 6.022 into 9.108 or 9.1 in numerator will be having 10 raised to 8. So these many moles will be having, or will weigh 1 kilogram. Right, so this completes 8 questions based on mole concept. Thank you for watching.